Good day. I'm Michael from BSCE4B student. Now, I'm going to talk about the general characteristics of a contour. But first, before we proceed to the general characteristic of contours, I'm going to talk about the contouring. About what is a contours, a contour interval, a contour map, and then we proceed to the characteristics of contours. First, what is a contours? A contour is an imaginary line on the ground joining the point of equal elevation. Also, contour is the line in which the surface of ground is intersected by level surface. A contour line is a line on the map representing contours. Also, it is an imaginary line on the ground joining the points of some elevation are as called contours. Then, to the contour line. A contour line is a line drawn on a topographic map to indicate the ground elevation or depression. Usually, we can see the contour line in a map, so we can identify their elevations and depression. Then, we proceed to the contour map. A contour mapping is the delineation of any property in map formed by the constructing lines of equal values of that property from available data points. A contour map showing a contour line is known as contour map. A contour map gives an idea of the altitude of the surface, features as well as their relative position in plan serve both plan and a section. Then next, so let's take an example of a contour map. And the feature that you need to jump onto this map also of this squiggly line all over the place of that line is they called a contour map. They are called the contour line. So here's the map. If I locate the point Y on the map, I know its elevation is 500 meters. And I know that the point Y is directly located on 500 meter. A contour line, so by understanding the contour line, I know that any of the line is gonna have the same elevation. And the other line represents other elevation. So let's take a closer look on one the thing that you might notice that some of the contour lines, not all of them but some of them are labeled. For example, here the 500 line and the 600 line are labeled. This label by have been named, so these are called the index contours. Index contours are contour lines that are clearly labeled with their elevation. Now, unfortunately, most topographic maps, they are not enough room to be labeled the elevation of every single line, and this is why we use the index contour to maybe a very second line, one every 5th line or every 10th line depending on a map. Either way, oftentimes you will be given a contour interval. It tells you the elevation change from one contour line to the next. It tells you if it is increasing or decreasing. Now this map is clearly labeled to the interval of 50 meters, and what that means is that you go from one contour line to the next, so that the contour intervals tells you change from one line to the next. Fortunately, even if you are not a given contour interval, you can usually figure it out what it is by examining the line. Now, let's proceed about the characteristics of contours. Characteristics of contours shows distinct characteristic features of the terrain as follows. First, the all points on the contour line are of the same elevation. Second, closely spaced contour line indicates steep slope. Third, widely spaced contour line indicate gentle slope. And the fourth is equally spaced contour line indicate the uniform slope. Now these sketches are show 90 degrees, which is level with respect to lines now using steep slope, the gentle slope, uniform slope, and the plane surface. As you can see, in steep slope is very closely spaced. If you see an contour interval 10 meters, so it indicates 10 steep slope. So we remember this, if the lines are close to each other, it was called a steep slope. In uniform slope, and this is usually when you find on a map a contour line evenly spaced. Contour lines are usually evenly spaced apart, something like this, that would show that the contour line are evenly spaced apart, so the slope will be very uniform. Now here is an example of a topographic map. There's a couple features that you need to look at. Probably the most important is gonna be right at the very bottom. Sometimes you're gonna have cells that going to tell you linear distance between point. In this case, it's going to be in miles. And you also have probably even a more important features. It's gonna be a contour interval, which is represent in value from one line to the next. Now you notice that within your map you have one line that's labeled with 100. You see there's ocean surrounding your landscape here. So the ocean value is going to be 0. You notice that there's a 4 line in between the ocean value, then the 100 interval each line gonna increase by 20. So we first gentle slope, the one thing you look at simply gonna be spacing. Your line space of your lines gauge can be really close together, means that you have a very steep slope. Gradients. You have a big change over a very small distance. Will you compare that with the side of a mountain, of the side of the island? In this case, that the line are very gentle slope, and you have significantly lower gradient. You don't have as much as change over a specific distance, so that really as easy as it is in terms of differences between steep first gentle slope. It's all about the spacing of your line. One other feature I just want to kind of point is this. As you can see, the 1, 3, 4 with that little triangle with the dots, that we call the benchmark. Just give you an exact elevations on your landscape. So in this case, you see it's 134 feet. That's an exact elevation, and that's the specific point. Now we proceed about the characteristics of contour number 5. A series of contour lines on the map represent a hill if the higher values are inside. So this is the example. So as you can see, characteristic of contour number 5, that the closed contour line on a map represent a hill. So as you can see in the figure, that the inside value is higher than the outside. So it represents that there's a hill in the map, which is different from the number 6, which is the series of closed contour line on the map indicate a depression if the higher values are outside, which is different from characteristic number 5, that if the value outside is higher than the inside, it represents that there's a depression or a crater or a sinkhole. Next, to the characteristic of contour number 7. Contour line cross ridge or valley line at right angles. If the higher values are inside the bend or loop in the contour, it indicates a ridge. In number 8, contour line cross ridge or valley line at right angles. If the higher values are outside the bend, it represents a valley. Then we proceed to the number 9, which is no contour line can meet or cross each other either within or outside the limit of the map. Well, that there's an exemption out of this. Contour line cannot merge or cross one another on map except in these cases, which is the overhanging cliffs. A contour line never run into one another except in the case several contours coincide and the horizon equivalent becomes 0. In overhanging cliff, you see there's a cross line. Well, as the contour line, it cannot be merged or crossed except overhanging cliffs. In this figure, there's an overhanging cliff. You see a cross line, so there's a overhanging cliff. Next to the vertical cliff, you can see that the lines are separate, so it's same to the characteristic number 6. Then we proceed to the characteristic of contour number 10. Depression between summit called a saddle. It represented by 4 sets of contours as shown as it represents a dip in a ridge or the function of 2 ridges. And in this case of a mountain range, it takes the form of a pass. Now, I give example of solving a gradient first. Then we proceed to our example. I give example of solving gradient first. What is a gradient? Gradient is a measure, meaning we calculate is a slope, very steep or a very gradual. So let's take another map here. And in order to calculate gradients, we need a formula, which is the change in field value divided by distance. This can be found in earth science represent tables. Now, in this case, field values refers to the elevation. So we want to know how much does the elevation change over a given distance. So let's say we want to find the gradient between at x and y. So I have to find the elevation of x and y. Now point x is equals to 500 because it is on the line. So x has an elevation of 500. Now if you were to figure it out, the index via contour interval, you would see that there's 20. So we would see the point y has 400. So let's going to add 400 plus 20 is equals to 420. So I've got my change in field value and changes from 500 to 420. Now, I need to know that the distance of the bottom of the formula. Now, to get the distance, how to use the map scales. What you do is you would line it up with the point x and y like this. And I see that x and y distance are 2 miles away from each other. So the distance is 2 miles. So let's proceed to the formula. So the gradient is going to be equal in the change of the elevation, which would be 500 feet minus 420 feet divided by the distance of 2 miles. You can simply 80 divided by 2 miles, or this 80 divided by 20 miles, so you can get 40 feet per mile. So what this means is that if you were going to walk down this hill from x to y for every mile you travel, you would be getting 40 feet lower. That's all, and thank you.